Hello guys, welcome to another video. This one is paper 3 for A-level math, and this is the specimen paper for the year 2020. So this video will be really detailed so that you can understand how to solve each question properly. So with that being said, let's move on to question number 1. So here we have to find the set of values of x for which this equation is true, and then give your answer in a simplified exact form. So tip number 1 is, when you read your question, know exactly what it is asking you for your answer. So this is important for your full marks. So one by one, let's first solve this equation. So we have 3. We have 2 power 3x plus 1 less than 8. So here we are trying to find the values of x, so we have to make x become your subject of formula. So for example, I will first send the 3 over here. You will have 2 power 3x plus 1 less than 8 divided by 3. That's step number 1. Now I realize that the x value is on top. It is up. I will need to bring this down. How can I bring the x down? I will have to apply ln on both sides. So when you apply ln, you have to apply on both sides so that your equation does not change. Okay? So now we have to use this property. For example, whenever you have ln, let's say a power b, you can send this power down. It is equal to b ln of a. So same thing here, I can send this down. You will have 3x plus 1 times ln of 2 less than ln of 8 over 3. Okay, that is the other step. So now we have to try to make x become the subject of formula. So first we can try to divide by ln of 2. You will have 3x plus 1 is less than ln of 8 over 3 over 2. So one advice here is that when you divide by ln values, always make sure that ln of 2 is what? Let's check. Ln of 2 is 0.693. It is a positive value. Okay, so the reason why I want you to check those values, because sometimes ln of, let's say for 0.9, it can be, so ln of 0.9, it is actually negative value. So when you divide by negative for those inequalities, the sign will change, but this is just to check. You can see it is positive, so the sign remains the same. Okay, this is just to check. Now next step is to make x become the subject of formula. So we have 3x less than ln of 8 over 3 over ln of 2 minus 1. So now we can simplify. If you observe, basically here we have two fractions. This is 1 over 1, right? Now we can write this down as 3x less than ln of 8 over 3 minus ln over 2 over ln over 2. This is simple fraction subtraction. Now we want to combine those two together. How can we do that? So you have to use another property of logarithm. So for example, when I have ln of a minus ln of b, it is simply ln of a divided by b. That is only possible because these two are the same. Okay, that's why I can do that here as well, because I have ln and ln. So in this case, you will have 3x less than ln of 8 over 3 divided by 2. That will be over ln of 2. Now simplify. You will have 3x less than ln. That will be 1. That will be 4. So you have ln 4 over 3 over ln of 2. Now finally, we can have the value of x for your answer. So x will be what? Less than ln of 4 over 3 over divided by 3 ln of 2. Now again, you know this. We can send the power. Right here you will have ln of 8. Okay, so your values for x will be, x has to be less than ln of 4 over 3 divided by ln of 8. And this is the exact value, and the question was asking for a simplified exact value. And that should be your question number 1. Now let's move on to question number 2. So we have to expand this expansion in ascending powers of x up to and including the term in x squared. So we only need until x squared. So now to expand this, you have your formula to help you with that. If you guys don't know, you go back to your sheet of formula, you will see you have something like this to help you to expand this. So let's write this down. So on your formula sheet, you will see it says 1 plus x power n is equal to 1 plus n times x plus n times n minus 1 x squared divided by 2 factorial. So we can keep going on, but here we don't need to because we only care about until the term in x squared. So we can just stop right here. So same way, first thing we have to check is if this is 1, so this is also 1. So then we can use this formula. So to use this formula, we need to check if that is 1. That's the first thing we need to do. Now to use this, as you can see, here we have 1 plus 3x power minus 1 over 3. So compare those two, you can see x is actually 3x and n is actually minus 1 over 3. So now next step is pretty easy. We just have to substitute back in the expansion. So 1 is 1 plus n is minus 1 over 3 times x is 3x plus minus 1 over 3 times minus 4 over 3 and times x is 3x squared divided by, so what is 2 factorial? 2 factorial is just 2 divided by 2. Now we can simplify. So the first thing is we can just cut this out. Okay, so you will have 1 minus x. And what is this simplification? You will have, let's do this on the side. Okay, on top you will have, so minus minus become plus, so 4 over 9 times 9x squared. And this divided by 2, right? So 9 will cancel out. You will have 4x squared divided by 2, that will be 2x squared. So you will have plus 2x squared. So this expansion will give you these 3 terms until the term in x squared. So now this is only possible when this is 1. Now what happens if it is not 1? I can show you guys what to do. So for example, I have to expand 2 plus x power minus 1 over 2. What would you do? You will first have to make this become 1 by factorization. So you will take out the value of 2. You will have 1 plus x over 2 and the power will be outside, right? Now we can bring this in. You will have 2 like this and 1 plus x over 2 power minus half. So now we can expand this because here we have 1. We can use this formula. So this one is just a side note for you guys to know. If this is not 1, this is how you make it become 1. That is for part A. Now let's move on to part B. We have to state the values of x for which the expansion is valid. So we have this expansion which is 1 plus 3x power 1 over 3. Now going back to your list of formulas, you will see it is valid when this is true. So given that we know x here is 3x, you have to write when this is true. So x will be less than 1 over 3. So basically pretty simple. When you make this become 1, you have to take this value here, which is this value, modulus this value has to be less than this value. Now let's change that a bit. Let's say you want to find the values of x for which this is true. So 1 plus, let's say I have 4x power minus half. What is the values of x? You will just take this value here, which is modulus of 4x will be less than 1. So you will have modulus of x like this. Okay, so it's this technique to find the set of values of x for which this is valid. And that will be your question number 2. Now let's move on to question number 3. So here we have to sketch the graph of y equal to 2x minus 3. So the first thing I like to do is I like to first ignore the modulus. I like to write down y is equal to 2x minus 3. Okay. then I like to find 2 points where I can draw my line. For example, I would say, okay, let's assume x is 0, y will be minus 3, and assume y is 0, x will be 1.5. So now I have 2 points to plot, which is the point 0, minus 3, and 1.5, 0. So let's draw the x and the y-axis for this graph. Okay, here we go, and that will be our x-axis. Okay, let's mark them. So 1, 2, 3, 4, 5, 6. Top will be 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, that is your x, and that is your y. And the first point here I have is 0, minus 3. So let's label this minus 1, minus 2, minus 3. That's the first point. Have 1.50. So let's do this as 1 and 2. 1.5 will be right here. So basically, from what I can see, also let's do that 1, 2, 3. So at first I will pretend to draw the line in this direction. So basically I will start drawing the line, but I will not draw the line going below the x-axis. Okay, I will start right here because everything below has to be reflected upwards because of the modulus sign. Modulus means it cannot be negative. Everything going down has to be reflected upwards. So 0 minus 3 becomes 0, 3. Okay, now we have to join those two to complete your graph. And that will be your answer number 1, part 1. Now for part B, we have to solve this inequality. So whenever you have two inequalities, when you have modulus, you can try to just square both sides. It will make it easier for you. Okay, so you have 3x minus 1 square more than 2x minus 3 square. Then you will have 9x square minus 6x plus 1. That will be 4x square minus 12x plus 9. Now we have to send everything to one side. So 9 minus 4 is 5x square. Minus 6 plus 12 will be plus 6x. Plus 1 minus 9 will be minus 8 more than 0. Now whenever we have to solve an inequality function, we first have to find the critical values. So basically we take the same function, which is this one, and we equate that to 0 to find the critical values. Now we just have to solve by factorization. That is 5x times x. 8 is 2 times 4. Now to get plus 6, we have to do plus 10 and minus 4. So x will be equal to 4 over 5. X will be equal to minus 2. So these two are the critical values of this equation. So now to find the values, we have to draw a graph. So this is your line of 0. And since this is positive here, it will look like a minimum curve. This is your two critical values. This is 4 over 5. This is minus 2. So the question asks us for the value above the line. So above 0 will be for this one and this one, right? So that is only possible when the values of x is less than minus 2 and the values are more than 4 over 5. So now we have two possible set of values for x for this equation, but now we have to choose which one is valid based on your graph. So let's draw this line, y equal to 3x minus 1. Let's find 2 points. When x equal to 0, y is minus 1. So that's the first point. And when x equal to 2, or just 1, why not? Y is equal to 2. So 2, let's say, will be about this point. It's only a sketch. So now by joining those two, you will form a, sorry, it's 1, not 2. Okay, 1, 2. 1, 2 should be right here. Okay, so you gotta be careful. Now let's join those two lines. Those 2 points, you will form your line. And this line will be y equal to 3x minus 1. So as you can see, it meets the point, the curve, the modulus curve at only one point, and it is on the positive value of x. So this value here has to be a positive value, which is basically the 4 over 5. Okay. So in that case, you can see the condition. It is, this line is more than the modulus only when after this point it is more than the modulus sign. So in that case, you will just choose this value as your answer based on your graph. Okay, so that will be x is more than 4 over 5. That will be your answer for your question number 3. Now another tip is, whenever you are going to do your paper, do question one by one. Don't look at all the questions at first, because let's say if you look at all the questions and you see one question which is really hard, then you will be stressed all the way along. So it's not good for you. You want to do one by one by going through the paper. And then let's say if you don't know an answer, I would say don't waste too much time on that. Just skip it for now. Come back to it later. That's the end of the advice I have for you to save some time. Okay. Now let's move on to question number 4. So we have the parametric equations of a curve are these two. So where t is a positive value, okay, now when t is equal to a, the gradient of the curve is 2. So whenever we mention the gradient of a curve, you have to know that gradient is dy by dx. So dy by dx is equal to 2 when t is equal to a. So we have to use that information to show this. Show that a satisfies this equation. So we have to first find dy by dx. So now how do you find dy by dx from these two equations? So we have to form something that connects these two. So if you observe, dy by dx is equal to, on top we have dy, and on the base we have dx. Now what is common between those two? If you observe the equation, they have t in common. So that will be dy by dt times dt by dx. So dy by dx equal to this times this. So let's find one by one now. So first one is x is equal to exponential 2t minus 3. So let's find dy, the dx by dt. That will be, you write the same thing and multiply by the differentiation of this one, that will be 2. Your answer will be 2 exponential 2t minus 3. That will be dx by dt. But here we're looking for the values of dt by dx, so we have to flip this upside down. That will be 1 over everything, which is 2 exponential 2t minus 3. That is this value. So next one we have to find dy by dt. So dy by dt is what? Y is given to you by 4 ln of t. Now dy by dt is equal to 4. It is only a multiple, and this becomes 1 over t. So that will be 4 over t. Now since we have those two values, now we place back in the main equation to find the value of dy by dx. Okay, so dy by dx is equal to 4 over t multiplied by 1 over 2 exponential 2t minus 3. That will be 4 over 2t exponential 2t minus 3. Okay, so now we have found the value of dy by dx. So now we have to use this. We know when t is equal to a, the value is 2. So replace. We know t is equal to a, dy by dx is 2. So replace replace a in this equation. You will have 4 over 2 a exponential 2a minus 3 is equal to 2. Now 2 is 2 over 1. Now we can simplify. So if you observe, here we have 2, that will cancel out, and here we have 2, they will also cancel out. Now we can cross multiply. You will have 1 is equal to a exponential 2a minus 3. Now we can send the value of a over here. You will have 1 divided by a is equal to exponential 2a minus 3. Now, what is this value? You realize we can also write this down as a power minus 1, right? So right now you will have a power minus 1 exponential 2a minus 3. So now we have to make a become the subject of formula, so we have to send exponential over here. How can you do that? So you have to know whenever you have exponential of a value a and you want to eliminate this, you can always write a is equal to ln of b. So same way, you will have 2a minus 3 is equal to ln of a minus 1, power minus 1. Now next step, if you observe this, we have power here. We can send the power to the front. You will have 2a minus 3 is equal to minus ln of a. Now 2a is equal to 3 minus ln of a. A will be equal to half times 3 minus ln of a. And this is shown as required exactly right here. That will be for part A. Now let's move on to part B of this question. So verify by calculation that this equation has a root between 1 and 2. So right now our equation is a is equal to half of ln 3 minus ln of a. So here we don't have ln, sorry. So we have to test one by one. I have to begin from the value of a equal to 1. That is my left hand side value, which is this one, is 1. Now what is my right hand side value? Replace the value of a in the equation. You will have half ln of 3 minus 1. Okay, sorry, it's not ln, so half of 3 minus ln of 1. That should be 1.5. So as you can see, the left hand side is less than the right hand side. That's the first part. Now going here, we have to write a is equal to 2 for this value. Now what is this value? Replace back in the equation. You will have 1.15. So right now you have left hand side and right hand side. The value of a is more than the right hand side. As you can see, the sign has changed, and if the sign has changed, it means that the value of a will be between 1 and 2. So let's write this down. Since the sign has changed between the values of a equal to 1 and a is equal to 2, we conclude that a lies between 1 and 2. So that is the conclusion we can draw from this. Okay. Now let's move on to part B. Using this equation, we have to calculate the value of a correct to 2 decimal place. So that's your final answer, showing the result of each iteration correct to 4 decimal place. So we have to let the first value is equal to the midpoint of those two, that is 1.5. So let a equal to 1.5. a2 will be what? Replace back in the equation. So let a equal to answer. Okay, this is the first one. Then we have half of 3 minus ln of answer for the second value. So let's do that. You will have 1 point. So let me try again. So just to confirm, that is half. Wait, let me try. So 1.5 will be answer. Half of ln. So we don't have ln. I always make this mistake. I don't know why. Half 3 minus ln of 1.5. That will be, okay, 1.29. 1.2973. Okay. But here I use 1.5. Let me try again now. That should be actually answer. So half. So let's use 1.5 as your answer. Okay. So half 3 minus ln of answer. Okay. That will be this first value. And next value will be 3. 1.3699. Then I have a4 will be 1.3426, 1.3527, 6, 1.3490, A7, 1.3503, we have A8, 1.3500, A9, 1.3500, and then we have A10, which is also 1.3499. So in that case, I will just stop right here. I will take my value as A is equal to 1.35, correct to 2 decimal place. And that is your value of A for question number 4. Now let's move on to question number 5. So we have to show that dy by dx of this equal to this. So one by one, we can first expand this. You have d by dx of x minus d of dx of tan inverse of x. That is equal to 1 minus. Now this thing here is given to you on your list of formula. You can check. As you can see here, you will have function is tan inverse, and differentiation will be 1 over 1 plus x. This is 1 over 1 plus x squared. Now we can simplify. As you can see, these two are just two fractions. That will become, you have the same base by 1 plus this. Then we can cross multiply. You will have 1 plus x squared minus 1. That will become x squared over 1 plus x squared. And this is your answer for this one, shown as required. Now let's say you want to know how to find that value. We can do this on the side. So to find the differentiation of this, we have to use let y is equal to tan inverse of x. In that case, tan y will be equal to x. Okay. Now we can find dx by dy. You will have sec square y. So now we want to find dy by dx, not dx by dy. So we have to flip this upside down. That will become 1 over sec square y. Now from your list of formulas, you have to know that sec square y is actually equal to 1 plus tan square y. Now tan y is x, tan square y is x squared. Replace back in your main equation, you will have dy by dx is equal to 1 over 1 plus x squared. That's why you will get this for this one. Okay, that's why you get this value. This is shown as required. Now for part B, we have to show that this is equal to this. Now usually you will take the value of u as x and dv by this. But since this one is inverse of tan, you will take this one as your u and this one as your dv to find this by parts, right? Integration by parts. So let's find the equation. We know that equation is uv minus v du. So we know u is equal to this tan inverse of x. We have to find du by dx is equal to the same thing here, which is 1 over with same, right? Du by dx will be 1 over 1 plus x squared. Now we know dv is equal to x, so v will be x squared over 2. Now just replace every value back in the equation. Okay, so you will have u is tan inverse of x times v is x squared over 2 minus integration of v is this one, times du is 1 over this times dx, sorry, so dx, right? Now we have to simplify. So first thing here, we can just send this one in the beginning. You will have x squared over 2 tan inverse of x. Now let's take out the value of half. You will have minus half and integration of x squared over 1 plus x squared dx. Well, now if you observe, we should know this value from part A. Why? Because if you see, when you differentiate this one, you get this one, which is the same as this one. So it means that if you integrate this one, you should get this value. So basically, this value is equal to x minus tan inverse of x. Okay, so we just have to replace and solve this equation. So let's do one by one. So basically, right now we have x squared over 2 tan inverse of x minus half times x minus tan inverse of x. Of course, we have to write down the limits between root 3 and 0. Okay. Now, one by one, we have to simplify. First, put the value of root 3 in the values of x. You will have, let's use a different color here. You will have, what is root 3 squared? It is 3 over 2 tan inverse of root 3 minus half of root 3 minus tan inverse of root 3. Okay, that is the first part. Now we have to minus the 0, 1. You have 0 times something will be 0, minus half 0 minus 0. So this whole thing will be 0. Now we just have to simplify these values. Now what is tan inverse of root 3? That is, if you compare with degrees, that should give you 60 degrees. So write this down. Tan inverse of root 3 is 60 degrees, and that is pi by 3 radians. Replace back in the equation, you will have 3 over 2 times pi by 3 minus 1 over 2 times root 3 minus pi by 3. So now we can just factorize the value of half outside to see what happens. Half, you will have 3 over 3 minus root 3 over 2 plus pi over 6. Right, because it's out. I made a mistake now again because I took it out already, so I should not be writing this. So always step by step. Okay, let's try again. You took the value of half out, you will have 3 pi over 3 minus root 3 plus over 3. Now we have to add these two. So 3 pi plus pi is 4 pi. So 4 pi times half. So let's leave the half outside for now. You will have 4 pi over 3 minus root 3. Now we have to simplify. So we have to bring this in. You will have 4 pi over 6 minus root 3 over 2. Now here we can simplify this. Divide by 2, you will have 3, and that will be 2. That will be 2 pi over 3 minus root 3 over 2. And this is shown as required. So same thing as this one. Okay, and that will be your question number 5. Let's move on to your question number 6. The complex number 1 plus 3i and 4 plus 2i are denoted by these two values. So we have u is equal to 1 plus 3i and v is equal to 4 plus 2i. Now we have to find the value of u divided by v. U is 1 plus 3i divided by 4 plus 2i. Now if you want to simplify something like this, you have to multiply by the conjugate of this one, which is 4 minus 2i on both sides. So now just to test this with you, what is the conjugate of 2i minus 4? Okay, so the first thing you need to do is to rearrange this by writing down minus 4 plus 2i. So the conjugate will be minus 4 minus 2i. Okay, so just to explain how to find the conjugate of complex numbers, we have to change the sign before the imaginary of number for this one. Okay, that's how you find the conjugate. Now let's simplify one by one. So let's say for the base, how can we simplify? You will have 4 plus 2i times 4 minus 2i. So if you observe, this looks a lot like a plus b times b minus 1, which is equal to a square minus b square. So same way, this will equal to 4 square minus 2i square, which is 16 minus 4i square. I square is equal to minus 1. That will be 16 minus 4 times minus 1. That will be 20. So the base will become 20. Now how about the top? Let's check. The top we have 1 plus 3i times 4 minus 2i. Let's first expand this. You have 1 times this will give you the same thing. And we have this times this will give you plus 12i. Then we have minus 6i square. So same thing here. I square is minus 1. So firstly we have minus 2i plus 12, that is 10i. And here we have 4 plus, then here we have minus 6 times minus 1. That will become 10 plus 10i for the numerator. Now replace back in the main equation. So u over v is equal to 10 plus 10i divided by the denominator, which is 20. Now we can simplify by divide by 10 everywhere. You will have 1 plus I 2, that will be half plus half of I. So finally you can write down u over v is equal to half plus half I. This is your answer for part A. Now for part B, you have to state the argument of u divided by v. Now we know that u divided by v is equal to half plus half I. So to find the argument of this value, it is just tan inverse of this value here, which is half, divided by this value, which is half. And that gives you tan inverse of 1, which is equal to pi by 4 radians, which is 45 degrees. And this is your answer for part B. Now let's move on to part C of this question. In an Argand diagram with origin O and the points A, B, and C represent the complex numbers u, v, and u minus v. So basically we know u has been given to us by 1 plus 3i, v has been given to us by 4 plus 2i. What is u minus v? That will be 1 plus 3i minus 4 plus 2i. So 1 minus 4 is minus 3 plus 3, that will be plus I. Okay, that will be u minus v. It is this value. Now to understand the relationship between those two, we have to draw the Argand diagram. Okay, just to understand what's happening, it is always best to draw the diagram. So here we have your imaginary axis, and here we have our real axis. Okay, we have to label those. And let's just take those as values here. So this is 1, 2, 3, 4, 5. This is your I, M. This is your real numbers. Okay. So here we have 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3. 1, 2, I, 2i, 3i, 4i, and 5i. So the first point here we have is A. A is u. U is 1 plus 3i. So 1 plus 3 will be about right here. This is your point A. Now point B is V, which is 4 and 2. 4 plus 2 will be, this is your point B. And the point C is u minus v, which is minus 3 plus I. That should be about here. This is of course your point O. Now we want to find the relationship between OC, which is O going to C, and then BA, B going to A. As you can see, they are parallel with each other. So let's write this down. So we determine that OC is parallel to BA. Okay, that will be part C of your question. Now let's move on to part D. We have to show that angle AOB is equal to this value. So where's angle AOB? So let's find out. You will have A here, go into O, and we have to go to B. So we have to find this angle. So now you observe, how can you find this angle? You can first find the argument of A, and then minus the argument of B to find this angle. Now you guys know already A is equal to actually U, and B is actually V. So let's write this down. The angle AOB is equal to argument of A minus argument of B, which is argument of U minus argument of V. So now, just like logarithm, we can combine these two together. So we have to use argument of U divided by V. Now if you look at this, we have found the value already in the first part. If you remember, from part B we know this is argument of U over V equal to this value. So same thing, that will be equal to pi by 4 radians. This is shown as required. And that will be your question number 6. Let's move on to question number 7. So by first expanding this term, express this as this. So first thing first, expand this. Okay, you will have cos of x plus 45, that is equal to, so this expansion is also given to you on your list of formulas, as you can see here, cos of A plus B. Okay, so you don't need to memorize this one. That will be cos of x, cos of 45 minus, becomes minus, sorry, and you have cos of, so it becomes sine of x and sine of 45. And we have to simplify this now. So here we have exact values that we can find. So cos of 45 is what? It is 1 over root 2. So you need to know those values. And sine of 45 is equal to 1 over root 2. So you need to know these values for exams. And also for those values, what is cos of 60? It is half. What is sine of 60? It is root 3 divided by 2. What is cos of 30? We root 3 over 2. And what is sine of 30? It is half. So you have to know all these values for your exact angle. So make sure you memorize this before exam. It is important to know the exact values. Okay, so now we just have to replace back in the equation. You will have cos of x, this will become 1 over root 2 minus 1 over root 2 sine of x. Okay, so this is this by expansion. Now we have to replace this back in the main equation now. So right now we have 1 over root 2 cos x minus 1 over root 2 sin x minus root 2 sin x. So how can we simplify this? If you observe, we can factorize the minus sin x outside. You will have 1 over root 2 plus root 2. Okay, so let's simplify this. So that will be 1 over root 2 plus root 2 over 1, which is equal to 1 plus 2 over root 2. That will be 3 over root 2. Now replace back in the equation. You will have 1 over root 2 cos of x minus 3 over root 2 sin of x. Okay, that will be your answer for this simplification. Now we have to transform this to something like this. Okay, so pretty easy. Now the value of r, it is always going to be this, which is square root of the square of the first value, this one, plus square of the second value, that is 1 over 4, sorry, over 2, plus 9 over 2. That will be 10 over 2, and that should be root of 5. Now, based on the question, it tells you to give the value of r correct to 4SF. So you have to provide that to 4SF. Root of 5 will be 2.236 4SF. Okay. Now to find the value of alpha, that will be tan inverse of this value right here, which is 3 over root 2, divided by this value, 1 over root 2. Now since both are over root 2, they can just cancel out. That will give you tan inverse of the value of 3. That will be 71.57, correct to 2 decimal place. So always read the question and to see what they are asking you for. The value of alpha correct to 2 decimal place. Okay, so right now you have these two values. Replace back, you will have r is 2.236 times cos of x plus 71.57. Okay, so that will be the value for your equation, this one. Now we have to move on to part B. Part B tells you to hence solve the equation. So whenever you see hence, you have to use your answer for your previous part, because here you can see that this actually became something else. You have 2.236 cos of x plus 71.57 is equal to 2. Now next step is to make cos become your subject of formula. That will be 2 divided by that. 2 divided by 2.236, that will be 0.89445. Now, cos is positive. It has to be in your first quadrant and your fourth quadrant. First is the angle, and this one will be 360 minus this. Okay, so x plus 71.57 is equal to cos inverse of that. That will be 26.6 degrees, which is the first value, and this one we have to find this one, which is 360 minus 26.6. That will be 333.4 degrees. But now we have to find the value of x, obviously. So we have to make x become the subject of formula. So x will be 26.6 minus 71.57. You will have minus 44.97, and 333.4 minus 71.57, that will be 261.83. Now, whenever you have a negative value, you can try to add 360 to them to see what happens. So minus 44.97 plus 360, that will give you 315.03. So finally the values of x has to be 261.8 and 315.0. So these two values will be inside the domain that we need. So x has two values to satisfy the equation. And that will be your question number 7. Let's move on to question number 8. So in the diagram below, we have OABC is a pyramid in which OA is 2 units, OB is 4 units, and OC is 2 units. The side, the edge of OC is vertical, it is going up, and the base is horizontal. Now this is 90 degrees. Unit vectors of I, J, and K are parallel to OA, OB, and OC, which means OA is actually 2I, OB is 4J, and we have OC is 2K. Okay. Question number 1 is to find the values of vector ON. How would you find ON? If you observe O going to N, we're going to first do O going to B, B going to N. Now we know that m and n are the midpoints of those two lines. Okay, so let's write down. From O we have to go to n, so from O we can go to B, B going to n. So O going to B and B going to n. Okay, so OB we know already, it is 4j. And what is BN? BN is half of BC. So how would you find BC? BC is just OC. So let's write down BC will be BO and OC. BO is minus 4j plus 2k. So half of BC minus 2j plus k. Now replace back in the equation. Half of BC is BN. Now will be minus 2j plus k. So your answer will be 2j plus k. So you have to you can write this down like this, or you can write in terms of a vector which is 0 to k. That will be On. Okay, I think the answer should be in terms of ij and k, so it should be this one. Okay, so you don't need to convert this to this because of the condition here. Now we have to write down Cm. What is Cm? If you observe C going to M, we can first go C going to O going to A going to M. Okay, so let's write this down. That will be C going to O going to A, and then A going to M. Now CO has been given to you as well as minus 2k plus 2i, and AM is half of AB. Now what is AB? AB is AO OB. Okay, so AO is minus 2i plus 4j. Now half of AB will be minus I plus 2j. Replace back, you will have minus 2k plus 2i minus I plus 2j. So your answer will be 2i. Sorry, we have 2i minus 1, that should be I. Then we have plus 2j and then minus 2k. So this is your answer in terms of ij and k for Cn. Now we can write this down just for us, not for the answer. So we can note this also as 1, 2, minus 2. Okay. This is for afterwards, right? Now let's move on to part B of the question. Calculate the angle between the directions of ON and CM. So since we know the two directions already, we can find the angle directly. ON is equal to 0, 2, 1, and CM is equal to 1, 2, minus 2. So now we have to use our formula to find the angle, which is dot product of those two directions is equal to modulus. So to find the size of both, modulus of both, times cos of the angle. So let's replace the values. ON is just this vector, 0, 2, 1. CM is 1, 2, minus 2, is equal to, what is this value? Let's find out. That will be 0 plus 4 plus 1, that is root of 5, and CM will be, that will be 1 plus 4 plus 4, that will be root of 9. So root of 5 times root of 9 cos of theta. So let's find out what are the this one. So 0 times 1 plus 4. So this is 0 plus 4 is 4, minus 2 is 2. Cos of theta. So cos of theta is 2 divided by root of 45. So theta will be cos of inverse 2 divided by 45, right? So 2 divided by root of 45, cos inverse of that, sorry, you have 72.6.7. Okay, that is the angle between those two directions. That is for part B. Now for part C, show that the length of the perpendicular from M to this point is this value. So let's observe. ON is this line, right? we have the point M here. We have to find the length of the perpendicular to this one. So let's make a drawing here to see what's happening. So we have a line ON, and we have the point M here as well, and we want to find the length of the perpendicular. Okay, so let's call this point here as the point P, for example. Now, to find the length of the perpendicular, we have to find the vector PM. Now, to find PM, we need to know OM minus OP. So first find OM and then find OP. So how do you find OM? Going back to your diagram, OM is equal to OA and AM, right? So let's find the value first. So OM is OA plus AM. OA is given to you by 2i. AM is half of AB, which is also given to you by minus 2i plus 4j. That will be 2i minus I plus 2j. That is I plus 2j. That is the value of OM. Now we can write down OM as the point 0, 2, sorry, this is 1, not 0. 1, 2, 0. That's the point of OM. So that's the first thing we need to find. Now, how can you find OP? We have to form an equation, because as you can see, OP lies on ON. So that means we can have these 3 points are collinear. So we can write down OP is equal to, let's say, T times ON. So this is an equation we can form because P lies on ON. Okay. Now T is T. It is a factor times ON is given to us by 0 to 1. That will be 0 to T. Now going back to here, to find PM, PM is equal to what? OM is 0 to T minus OM. So it's actually the other way around, OM minus OP. Okay, let me write that again. So PM is OM 1, 2, 0 minus OP, which is 0 to T. That will be 1 minus 0 is 1. That will be 2 minus 2t and minus t. That is direction PM. So now we have to find the value of t. So how can you find the value of t? You have to look at this diagram. As you can see, OP is perpendicular to this line. So we can use dot product equal to 0. So basically we can use OP dot product PM has to give you the value of 0. So let's do that. OP is this, which is 0, 2, and t times PM, which is 1, 2 minus 2t. This is equal to 0. Now solve, you will have 0 times this will be 0 plus 4t minus 4t square. Then we have minus t square is equal to 0. So which is 4t minus 5t square is 0. So 5t square minus 4t is equal to 0. Now we can find the value of t. So t factorize out, you will have 5t minus 4. So we will not take t equal to 0, obviously. You can cancel out. T will be 4 over 5. So for this value of t, we can find our vector PM. So PM finally is equal to 1 and 2 minus, so 2 minus 2 times t, which is 4 over 5. That should be 2 over 5, and last one minus 4 over 5. So now we have to find the length of PM. So let's find some space. Let me do this here. So finally we have PM, which is the perpendicular line, is equal to 1, 2 over 5 and minus 4 over 5. So what is the modulus of that? That will be square root, square the first value, which is 1, plus 4 over 25 plus 16 over 25. Now if you simplify everything over 25. So 25 plus 4 plus 16, that should give you 45. Now you can simplify this value. So 45 is 9 times 5, and 25 is 5 times 5. Sorry, yeah, exactly. Now take the value outside. 9 can be 3 root 5, and this is over 5. And this is the same as this, shown as required. Okay, and that will be your question number 8. Okay, that was a long question. Now let's move on to question number 9. So we have to solve this equation. So let's see what we have to solve. Okay, the diagram shows the curve y between those two values, 0 and half pi, and it has a maximum value of point m. This is the maximum value of this equation. Now part A, find the coordinate of m. So how can you find the coordinate of m? Because we know it is a maximum, we know this, right? At max point, we know dy by dx have to be 0. So we have to find dy by dx. So y is given by this. Dy by dx will be what? As you can see, this one is a product. We have to use the product rule. So first I can just take cos x, leave it by itself, and times d by dx of this one. You will have 2 sine of 2x multiplied by cos of 2x times 2. Then we have to plus, and then we have to leave this value as it is, which is sine square of 2x times differentiation of this one will give you minus sine x. So simplify, you will have this 2 times 2 is 4. That will give you cos x sine 2x and cos 2x minus sine square 2x and sine x. Now as you can see, we have to equate that to 0 to find the stationary point. Now first thing, we can divide by sine 2x. This will go away. Then we can replace the value of this one, right? If you observe back on your list of formulas, you will see that sine of 2x is equal to something, this one, sine of 2a plus, so not plus, sine of 2a times cos of a. So that will be 4 cos of x cos of 2x minus 2 sine of x cos of x sine of x equal to 0. Now we can divide by cos x. This will go away, and you will have 4 cos of 2x minus 2 sine square x equal to 0. Okay. Now next step is, since we have x here we have 2x, we have to change this one. So again, going back to your list of formulas, you will see that cos of 2x is equal to, right here, we can use this one, 1 minus 2 sine square a. So replace, you will have 4 times 1 minus 2 sine square a minus 2 sine square x is equal to 0. So let's simplify. You will have 4 minus 8 sine square a minus 2 sine square x. Sorry, it's x, not a. That's the formula, so we have to be the same now. So now since we have x the same, we can combine them. You will have 4 minus 10 sine square x is equal to 0. Now we have to make sine square become the subject of formula. So sine square x is equal to 4 divided by 10, which is 2 divided by 5. So sine x will be root of 2 divided by 5. Okay, we'll take the positive value because, as we can see, it is in your first quadrant. Okay, now value of x will be in terms of radians. So first let's find the square root of, so 2 divided by 5, square root of that, and we have to find sine inverse of, in terms of radians, 2 divided by 5 root, that will be 0.685. X will be 0.685. that will be your value of x. Okay, that is for part A. Now let's move on to part B of the question. So here we have to use the substitution u equal to sine x to find the area of the shaded region. So right now we have integration of the angle of the curve, which is sine of 2x cos of x with respect to dx, and the limits are given to you by half pi over 0. Okay, so first step here is we have 2x, we have to change that. As you can see, sine of 2x is equal to 2 sine x of cos x. Now we have to square, that will give you 4 sine square x and cos square x times cos x dx. That will be 1 over 2 pi and 0. So now we have to use the substitution of u equal to sine x. So u is equal to sine x, well, which means, so we can first find the value of du by dx. That will give you cos x. From this, as you can see, dx is du divided by cos x. Now we have to replace back in our main equation. You will have 1 over 2, 0. Here we have 4 sine x, sine square x is u square, cos square x we don't know yet, and times cos x times dx, which is du over cos x. So you can see that this we can just cancel out these two. So your value will be remaining as integration of 1 over 4 pi 0 4u square and cos square x by dx. So now how can we simplify this? As you guys know already, cos square x is equal to 1 minus sine square x. Replace back in your equation, you will have, so this is 2, 1 over 2 pi 0 for u square times 1 minus sine square x by dx. Now we know this is going to be u square. We just have to replace the values. You will have 2x over 0. This will become 4u square minus 4u power 4 by dx. So this is du, not dx. Dx is gone already. We have to use du. Okay, so here one thing we can do now is, if you want to change the limit, if you want to use the u, you have to change the limit. So as we know, u is equal to sine of x. So when x is equal to 0, what is the value of u? U will be 0. So this will be 0 as well. When x is equal to half pi, what is the value? Sine of half pi, that will be 1. So u is 1. So we can use u and change the limits. You will have 1 and 0. You can just keep the value of u now for the integration by du. That will become 4u cubed divided by 3 minus 4u power 5 divided by 5 for the 1 and 0. Now when this equals to 1, you will have 4 over 3 minus 4 over 5 and minus 0, of course. So 4 over 3 minus 4 over 5, it is 8 over 15 for your answer. So this is your area for the area under the curve, 8 over 15, and that is your question number 8. No, number 9, sorry, number 9. And I think now let's move on to the last question of this paper. In a chemical reaction, compound X is formed from two compounds Y and Z. Now, the masses of X, Y, and Z present at time t seconds after the start of the reaction is X, 10 minus X, and 20 minus X, respectively. Okay. Now, at any time, the rate of formation of X is proportional. So, rate of formation of X, which will be dx by dt, will be proportional to the product of the masses of Y and Z. So, Y is 10 minus X, and Z is 20 minus X. Okay, so now we have these two informations to find the values. So part 1, we have to show that x and t satisfy this equation. Okay, so how can we do that? If you observe, we can change proportional to equal sign k. K is your constant of proportionality, so we have to find the value of k. So right now we have dx by dt is equal to k times 10 minus x times 20 minus x. So let's use this value and this value to find the value of k. So dx by dt is 2 when x is equal to 0. So k, 10 minus 0 is 10, 20 minus 0 is 20. So k will be 2 divided by 200. That will be 0.01. Okay, so let's check. 2 divided by 200, 0.01. Or if you want to, you can write 1 divided by 100. Up to you, right? But finally, you have to write down dx by dt is equal to 0.01 times 10 minus x times 20 minus x. This is shown as required for this one. Okay, that is for part 1. It is only for 1 mark. It's pretty easy. Okay, now move on to part B. We have to solve the differential equation and obtain an expression for x in terms of t. That is part 1 and that is part 2 of the equation. So let's do part 1. We have to first solve the equation. So as you can see here, we have dx and dt. So we have to send all the x values to one side and we send dt to the other side. You will have 1 divided by 10 minus x times 20 minus x. That will be dx is equal to 0.01 times dt. So once you have this in this form, you can integrate both sides to find the two values that we need to solve this equation. Now this one will be pretty easy. It is a constant. It has to be 0.01 t and plus constant c. For example, this is for the right hand side, but now we have to find this side. So this one will be done step by step, because as you can see, this one we have two linear factors at the bottom, so we have to use partial fraction to break them up into two fractions. Okay, so let f of x equal to this, which is 1 over 10 minus x times 20 minus x, and let that equal to a on top over the first factor, which is 10 minus x plus b over the other factor. Now we have to solve this equation, equate that basically. So send this over here. So this value times this value first, you will have 1 here equal to a times 20 minus x plus b, this times this, so b over this times this will be 10 minus x. Now let's see what we have. We can verify the values. So we have to find the values of a and b. So let's first eliminate the value of b. So let's take the value of x to be x equal to 10, so that this can be cancelled. So b will be 0. That will be 1 equal to a. 20 minus 10 will be 10. So a has to be 1 over 10. Now one more time, you will have 1 equal to a 20 minus x plus b 10 minus x. Now let's eliminate a. So we take the value of x to be 20. That will be 1 equal to 0 plus b 10 minus 20 will be minus 10. So b will be equal to minus 1 over 10. Okay, so let's move on to the other page to have more space now. So basically from that we have known f of x is equal to a is 1 over 10, which is this factor, which is 10 minus x, and b is minus 1 over 10 times the other factor. Okay. This is f of x. And we have to find integration of f of x. That will be by dx, of course. We can first take out the value of 1 over 10. You will have this minus x, that become minus 1 over 20 minus x by dx. Now let's solve one by one. 1 over 10 is 1 over 10. And this one will become ln of the value here, which is 10 minus x, divided by minus 1, minus ln of the value here, 20 minus x, divided by minus 1, this one. So the question that I have all the time is, why did we divide by minus 1? This is because you have to understand, how do you integrate 1 over x? You would say that is ln of x. But it is not as simple as that. What we are doing is actually taking the ln of the value which is underneath and then dividing by the differentiation of this value, which is 1. So for example, what is this of 2x? You would say it is ln of this value here, which is 2x, then divide by the differentiation of this one. That's why we divide by 2. So same steps. When you take this value here, I have integration of 1 over 10 minus x. That will be ln on the value, which is this one, and then divide by differentiation of this one, which is minus 1. That's why we have to divide by minus 1. Okay, so that will be your answer on the left hand side. So right now, replace back in your main equation. You will have 1 over 10. So minus become plus. That will be ln of 20 minus x minus ln of 10 minus x equal to 0.01t plus the constant c. Now if you want to send this over here, you can multiply by 10 to eliminate this one. So you will have, let's multiply by 10 everywhere. You have ln of 20 minus x minus ln of 10 minus x is equal to, times 10, that will be moving one place, 0.1t plus, so 10c, we can write this down as a new constant k, plus k. So now we have to find this value of k. So how do you find this value of k? You go back to your question. In the first page, you see when t is equal to 0, x is equal to 0. So we have to use these two values to find the value of k. Observe. So x is 0, that will be 20 minus ln of 10 is equal to 0 plus k. From this, k is equal to ln of 2. So finally, you will have ln of 20 minus x minus ln of 10 minus x is equal to 0.1 t plus ln of 2. That is part 1 of the question, but now we have to express x in terms of t. That's the other part. So let's send every ln on one side. You will have ln of 20 minus x minus ln of 10 minus x minus ln of 2 is equal to 0.1t. So now to solve this, we have to know the properties of logarithm. So let's make a note here. So when you have ln of a plus ln of b, it is basically ln of a times b. And when you have ln of a minus ln of b, it is basically ln of a divided by b. So same thing here, we have minus, we have ln. So this is only possible when this one and this one are the same, okay? Let's say we had a log base of 2a plus log base of 10. So it would not be possible, okay? It needs to be the same, and then we can combine them. Now we have to ln of 20 minus x. So here we have minus, so we have to divide by this value, 10 minus x. And then here we have minus, we have to divide by this value, will be this. This is equal to 0.1t. So now, also we have to send ln over here. So as you have seen before, when you have ln of a is equal to b, to find the value of a, we send ln over the other side, you will get exponential b. So same steps, you will have 20 minus x over 2, 10 minus x is equal to exponential 0.1t. Okay, so now we have to simplify and cross multiply to see what happens. You will have 20 minus x is equal to 2 exponential 0.1 t times 10 minus x. So the goal here is to make x become your subject of formula, so we have to expand and simplify. So let's do this here. You will have 20 minus x is equal to 20 exponential 0.1t minus 2x exponential 0.1t. Now we can send this over here. You will have 2x exponential minus x is equal to 20 exponential minus 20. Now we can simplify. Let's take out the value of x here. You will have 2 exponential 0.1t minus 1 is equal to 20 outside. That will be exponential of 0.1t minus 1. So finally, this will be your answer. So x will be 20 exponential 0.1t minus 1 divided by 2 exponential 0.1t minus 1. This is your answer for part B of this question. Now finally, state what happens to the value of x when t becomes very large. And now for the last question is, what happens to the value of x when t becomes very large, basically going to infinity? So what can we do here is, let's say we can try to divide those values by exponential of 0.1t. You will have 2 and t is only a multiple. That will be exponential of 0.1t over exponential of 0.1t minus 1 over exponential of 0.1t. On top and below you will have 2 exponential of 0.1t over exponential of 0.1t minus 1 over exponential of 0.1t. That is one thing we can do when we have this kind of question to see what can happen. Okay, so now if t goes to be infinity, we know that exponential of 0.1 times infinity would also go to infinity. So basically these values will be cancelled. So this is pretty easy. This is same constant that will be cancelled to 1. I hope that makes sense, right? Let's say if you have a divided by a, that is basically 1. So right now we have 20, that will be 1 minus 1 over exponential infinity over 2 times 1 over exponential infinity. Now if this value is going to infinity, 1 divided by this value is going to give you 1 divided by infinity. That will be 0. If you look at this, that will give you 20 1 minus 0 over 2 minus 0. So finally you can say you will have 20 over the value of 2, which is 10. So that is your conclusion. You can write down, as t goes to infinity, the value of x approaches the value of 10 according to this breakdown. Okay, and that will be the last question of this paper. And just before you guys leave the video, just some few advice for you guys for the exam. So make sure that when you guys start your exam, always go through the questions step by step. Don't look at all the questions at once, because it may give you some stress, panic if something is hard. So one by one, go through the questions, and never leave a blank page on your paper, because you can always get part marks. And trust me, the part marks are always in the question itself. The question gives you a lot of information to solve your questions, so make sure you read your question exactly and understand what it is asking you for your answer. Okay, so with that being said, thank you for watching, and I will see you soon.